I'm ready to start whenever you...
Yes, Doctor, now ready. Thank you. Start now.
Can I start now?
Yes, yes.
Okay. Bismillah ar-Rahman ar-Rahim. You know that if you want to do some calculations in mathematics or statistics, nowadays, because the data usually is very huge, and therefore you cannot do your calculation by hand. Therefore, we have to use some software to do our calculations. There are a lot of softwares for statistics and mathematics, but for some of them, you have to pay a lot of money, and you have to buy a license, and usually every year you have to renew, and you have to pay again. But some softwares like R, Python, and some other software, a few of them are free. R is a free and powerful software to do many mathematical calculations and almost every statistical computations. You have to use R. You can use R for your data analysis, maybe low dimensional or high dimensional, huge data or big data, any of them you can use from R. Uh, you can do descriptive statistics and inferential statistics with R. The name R came from Robert Gentleman and Ross Ihaka, who firstly prepared this software roughly about 1991. Nowadays, this software is developing globally by many people around the world. Me and my students uh, had some contributions for developing or writing some packages, and you can find them on the internet. I will show you. And if you want, you can also write your own packages and add in the big library of R, and do your calculations. I mean, share your calculations, share your codes with other people. If you are interested to programming language, with R you can write simply your own function, and you can do your calculation easily. Because R is free, a huge number of researchers in research centers and academic centers in many countries have switched from other statistical software to R because it's free, and they have to pay for other software. Therefore, they switched from other software to R. I know many people in Australia, in Germany, in US, in Canada, in UK, in many countries, in Japan, in Austria, and many other countries that they switched from other software to R. Of course, there is uh, another free software named Python, and you can do your calculation with Python, but I think R is much simpler to do. And if you are in statistics, if you are doing some statistics or you are a statistician, I think R is much better. But I recommend you to learn both of them, R and Python. But I think installing and using R is much easier than Python. Okay. And it's good to know that R is very similar to S+. If you are familiar with S+, you can learn R very fast. In fact, Ross and Robert Gentleman and Ross Yohaka, as I told you, tried to make R usable with the handbooks of S+. I mean, they tried to make R without any handbooks, and they said, we are going to make a software that people don't need a new handbook. They can use handbooks of S+ to use R. I think it's interesting. Okay. With R, you can do a very simple calculations and advanced calculations. You can use from R as a simple calculator like this, as you can see here. For example, you can do a very simple calculation like 2 plus 5, 2 minus 5, 2 divided by 5, or 2 times 5, or 2 power to 5. I can show you in the environment of R very easily. It's the environment of R, and you can type here, for example, 5 plus 9, and you will give the answer, or 5 power to 9, and you can give the answer as again. This is the environment of R. Of course, there are another interface for R named RStudio, and you can yes. Okay. What about the voice now? Is it better now?
Yes, it's very good.
Thank you. Okay. There is another interface for using R named RStudio. Maybe some of you know about that. And here also you can do your calculation like this, or do your calculation like this. Okay. Let me return to the page, and I will let you know some other calculations that we can do with R, like natural logarithm with R. For ln of 5, you can use log of 5 or log of 5, and this is the answer. Or if you want to change the basement of logarithm, you can use log 10 of 5, or you can use this one. These two commands are exactly the same, log 10 5 or log 5 comma 10. They are the same. But if you want to use logarithm, or you want to calculate the logarithm of 5 based on, for example, 3, you can use log 5 comma 3. And therefore you can use from R as a advanced calculator. It's okay if you want to download R and use it right now with me. In the same time, I can show you that how you can download R and install it. Maybe it takes less than 5 minutes, I think. And then you can come with me this at the same time and type your own code, and you can see the result at the same time with me. If you want to download R, you can go to the you can go to CRAN, UMACIR, here. I'm not sure if you can see the URL, cran.um.ac.ir. If you go here, then you can go to downloads R for Windows, and then install R for the first time. And you can see it's the basic of R is very small, in spite of other software that maybe some of them you have to use one or two DVDs to install them, like SPSS, SAS, and other softwares. But for R, you can download it from the internet, from many mirrors, from many repositories. We have a repository of R in Firdaus University of Mashhad from roughly about more than 10 years. And you can connect to the University of Mashhad or other mirrors. You can see other mirrors here. There are a lot of mirrors for R that you can select any of them to download it. And this is the mirror of R in Firdaus University of Mashhad. Then you can go here, R for Windows, install R for the first time. And if you click on this, you can give R very quickly, and then just follow the instruction to install it. And after that, you will have something like this page, as well as me. I will give you roughly about 5 minutes if you want to download and run R. And after that, you can continue calculations with me. And also, there are some online free sites to use R. You can search on the internet online R, and there are some pages on the internet that you can use from R without installing it. And in this situation, you don't need a computer, a desktop or a laptop to use R. Just you can go to the address, to the URL with your cell phone, and you can use commands of R on the internet online without downloading the R. Okay, let me to continue and let you know what else we can do with R. Or for example, if you want to find exponential of 5, just you can type exp of 5 and you will give the answer. And for square root of 2, you can use sqrt of parentheses 2, And if you want to want to find the fifth root of 2, you can use this command, 2 powered 1 divided by 5. Note that 1 over 5 must be parentheses. And if you want to do some calculations on vectors, with this command, a equals to 1 colon 10, you can make a you can make a vector named a, and you can see the result of a here, 1 2 3 4 5 6 7 8 9 10. And after that, if you add 5 to a, the answer is this. Every element of a will be added to 5. Or for example, you can divide every element of a by 100, like this. Therefore, you can do many vector calculations with R. Or for example, a power 2. 1 power 2 is 1, 2 power 2 is 4, 3 power 2 is 9, and so on. 10 power 2 is 100. And you can use this as well, 2 powered a. It's 2 powered 1, 2 powered 2, 2 powered 3, and 2 powered 10, which is 1024. And you can, of course, define a vector with this. B equals to C. We are going to store a vector 2, 4, 3, 7, 0, 5, and minus 3 into B. It's very important that you have to note that R is case sensitive. It means that you cannot use capital C. If we go to R here, for example, if I want to define a vector like this, it's okay. But if I type capital C, I will give the error. Therefore, it's not okay if you change the capital to small or small to capital letter. You have to obey the rule. R is case sensitive. It's very important. And also for SQRT, for example, SQRT is okay for B, but SQRT is not okay. Okay? Of course, sometimes we need to write a capital letter, but if we don't need, we don't have to use that one. Okay, SQRT of B gives us this vector. It's a square root of 2, a square root of 4, a square root of 3, a square root of 0 is here, and a square root of 5. And for a square root of minus 3, we can see NaN because it's not defined. You know that a square root of a negative number is not defined. Therefore, we will give NaN, which is not defined. And the logarithm of B, you can give the answer again. You can see again, logarithm of minus 3 is NaN because it's not defined. And of course, in mathematical definition, for logarithm of 0, it's defined minus infinity. And we can see the answer here. And the trigonomic functions, again, we can use from R, sine of 2 radians here, sine of 2, or cosine of 2 radians as well, and cosine of P, excuse me, cosine of pi, yeah, which is -1. And note that the argument for sine, cosine, tangent are in terms of radians. If you want to find, for example, sine of 30 degrees, firstly you have to convert degrees to radian by dividing by 180 times pi, and then try to find the sine of the result, which we know that sine of 30 degrees is 0.5. And also, if you want to find the sine of 30 to 60 degrees, you can convert all of these degrees to radians. 30 to 60 degrees divided by 180 times pi, and then use sine to find all of them. Okay? And or if you want to find sine of 0, 15, 40, 44, 90 degrees, you can convert all of them to radians first and then use from sine function. And sine of 0, 10, 20, 30, you can use this one, or because 0, 10, 20, 30, 40 is a regular vector, you can construct this vector with SEQ. SEQ of 0 and 19 and 10, it means that we are going to make a vector starting from 0 and ending with 90 and stepped by 10. I mean, the result of SEQ of 0, 90, and 10 is, we can see here, SEQ of 0, 90, and 10. It's this. It's much simpler than writing C parentheses 0, 10, 20, 30, 40, 50, and so on. SEQ is a very useful function. Therefore, you can use it in many other positions in your codes. And after that, we stored SEQ of 0 and 90 and 10 into X, and then we divide X by 180 times pi to convert them to radians, and then sine of them, we can have the answers here. And of course, maybe we want to round them with 2 decimal points. We can use round of sine of X divided by 180 and so on, comma 2. If you write, for example, 3 rather than 2, you can get the answer with 3 decimal points. Okay. Now we are going to draw a plot with coordinates. Firstly, for example, if you want to draw the sine plot, we can make a vector from 0 to 360 degrees, stepped by 10, and then convert them to radians and find the corresponding y's. And after that, we can plot x comma y or plot y tilde x. These two are exactly the same. Plot x comma y or plot y tilde x. And this is the answer. Okay, it's the plot for sine from 0 to 360 degrees, which is 0 to 2 times pi in radians. Also, we can use another function to draw this plot named curve. With this function curve here, we can draw any other function as well, but the structure of this function is different from plot. With this function, we can say we can use curve of sine from 0 to 2 times pi, and simply we can have the plot here from 0 to 2 times pi in radians. You can use from curve for drawing any other functions like curve of exponential from -2 to 2, which is this one, okay? Or for example, curve of x2, x power 2 from -2 to 2. And of course, you can change the color of your curve if you want by adding this argument, COL. Therefore, curve of x power to 2 from -2 to 2, comma, color equals to red. And you can get the result here. With R, inside of R, if I want to draw a curve, for example, minus x power to 3 from -5, for example, to 5, comma, color, for example, green. We can see the answer here. And of course, I can change the Windows position like this. Okay. Instead of green, I can write 4 for another color. It's the number for any color. There is a number for any color. 3 is the same as green. 2 is the same as red. 5 is the same as cyan. Or 6 is the same as purple. Okay? Okay. And for example, if you have a function x2 minus 3x plus 1, and if you want to draw the curve of this function with green color and with a title, this is a title for your curve. You can change the title with this switch, with this argument, main. before parentheses, you can put a comma and main equals to any description that you want to put for the title of your curve. And this is the answer. It's green and it has a title. Okay. Any question till now, please? And,
No. Thank you. Thank you, Doc.
Okay.
No question. Thank you.
Okay. I hope till now everything is clear for you. Okay. Now I'm going to add a horizontal and vertical line to the above curve. With AB line, we can add a line to our curve. If you want to add a horizontal line at 0 position, you have to use this function, AB line, H, the abbreviation of horizontal, equals to 0 with the color yellow. And if you want to add a vertical line, you can use from this command as well. And the result is here. Okay? And if you want, I can share after that this PDF for you. And you can practice for your own. Okay. In this example, we are going to find the roots of the function. The roots of the function exactly, it's this position and this position. Okay? Where the function is 0. For this function, we have 2 zeros. One here, roughly about maybe 0.4, and another is here, roughly about 2.6 maybe. And we are going to find these two numbers. To find these two numbers, we can use another function named uniroot. Firstly, I have to define my function like this. F equals to functions of x power 2 minus 3 times x plus 1, and then I can use uniroot of f comma c minus 3 to 1. Why? Because it's uniroot, and at the same time it can find just one root for us, and we have to define an interval containing just one root. We can see from minus 3 to 1 we have just one root. Therefore, I wrote f comma c from minus 3 to 1, and the answer is yes, as I told you, it's roughly about 0.4, or exactly it's 0.3819409. This is the root. This is this position. Okay? Therefore, with R, we can find the root of a function. And for this other root, we can use this one, uniroot for the same f, but this time, okay. Before that, you can see that uniroot has a root as a result, and another item in the results. But we need just root. If we need just root, we can write uniroot of f, comma 3 from minus 3, comma c from minus 3 to 1. At the end, we can add dollar root. And in this situation, we can get just the root, not other information about uniroot. Okay? And using uniroot f from 1 to 3, we can get this answer as well. And adding dollar root give us 2.618. Okay? And of course, we can, with this example, we can find this point as well, which is the minimum of the function. We call it optimization. Where is the function? I mean, where the function is minimized or sometimes maximized. In this example, roughly about 1.5, I think, the function is minimized. For finding this one, we can use this function, optimize. Optimize from minus 3 to 3 gives us exactly 1.5. Okay. And in 1.5, the value of f is minus 1.25. It's, if you consider this one and come here, okay, here is roughly about minus 1.25. Okay. And this is the optimize. We can use optimize for maximize as well by adding an argument at the end of optimize. And of course, we can use from R to do some metrics calculations. And firstly, we have to define a matrix like this. M equals to matrix from 1 to 9, 3 by 3. And this is the matrix that we made. And exactly the same as vectors, we can do some calculations on a matrix like this. Every element of matrix times by 2, or every element of the matrix power to 2, or sine of every element of the matrix M gives us this. Okay? Or cosine, or logarithm, or exponential, or sqrt, or any other ones. And of course, to define a matrix, firstly, we can define a vector 4, 8, 1, 0, and then we can say matrix of S 2 by 2, and we can see the result like this: 4, 8, column by column. The vector, the elements of vector will go to the matrix column by column. First 4, and after that 8 for the first column, and 1 and 0 for the second column. And with solve of J, we can find the inverse of the matrix J. This is the inverse of the matrix J. Okay? And you know that if you multiply a matrix multiply by J by its inverse, it will be this matrix. And this operation, percent, star, and percent. Percent star percent means that we are going to do a multiplication, matrix multiplication. And the result will be 1001. You know that. And we have another command for matrix like eigen for eigenvalues and eigenvectors. Eigen-J gives us eigenvalues first and eigenvectors. The first column of this, the first column is the first eigenvector, and the first column of this, minus 18% and 98%, it's the second eigenvector. And the same as uniroot, if you type eigen-J dollar values like this from here, you can have just eigenvalues. And if you type eigenvectors, if you type eigen-J dollar vector, you can have a matrix containing just eigenvectors. Okay, another calculation with R that we can do is finding integrals. Okay, for finding integral from 0 to pi over 2 of sine of x2 d of x, we can define our functions. F equals to function of x, sine of x over 2, and then integrate of f comma 0 comma pi over 2. And this is the result. The result is 82.82. And also we can find the differentiation for a function like sine of x2, like this, with the command D. Note that for integration, for uniroot, we defined function, but for differentiation, we have to define an expression. It is the rule of R, and we have to obey that. Okay, K is expression of sine of x power 2, and then D, note that D is capital. Therefore, you have to use from capital D. Okay, D of K in terms of x. Because here we have D by D of x. And here you have to use D of K in terms of x. And this is the answer, cosine of x2 times by 2 times x. And if you want to do a double differentiation, you can use like this. K is the expression of sine of x2, and then h is differentiation, the first one, k in terms of x, and again d of h in terms of x will give your answer, which is this one, cosine of x2 times 2 minus sine of x2 plus, times 2 times x times 2 times x. And if you want to find a partial differentiation, you can use D again, but in this form. G is expression of sine of x powered y. And then with the first one, this one, if I can show you, just from D to parenthesis. Okay? Like this. D of J in terms of X will give us the first differentiation, derivation in terms of X. And again, we can apply another D over the first one in terms of Y. And this is the answer that you can see. Okay? Okay. There were some examples for doing mathematical calculations with R. Of course, there are a lot more, but I tried to let you know some main ones. And from now, I'm going to let you know how you can do statistical calculations with R. Some of them, of course, not all of them, because we need a lot of time to say about all of them. And maybe we cannot do this at all. Anyway, for doing statistical calculations, firstly, we need to define a vector of our observations. For example, if you, for example, measure something and you got the answers like 3.3, 5.6, 3.3 again, 5.6 again, 3.6, and so on. You can store them in X using C as a vector, and then table of X will give you the frequency table of X. It counts for you how many 3.3 we've had, how many 3.6 we've had, how many 5.3 we've had, and so on. Okay? Table of X will give us the frequency of each observation. And summary of X gives us minimum, the first quartile, the second quartile or median, mean or average, the third quartile, and the maximum number in our observation. Therefore, summary of X is another function in R for statistical computations. And if we need just the median of X, we can write median of X, or mean of X, for example, we can use that one. If I can copy and paste this into my R, I will show you. Okay, this is my X. Okay, for example, mean of X or median of X, or standard deviation of X, or variance of X. Okay, yeah, median of X here, and after that, yeah, we can find quantiles of X in any percentage that we need. For example, 50% is the same as the second quartile or median. Okay. or maybe quantile of x. If we need quantile of x in 80%, we can find it with this command, quantile of x 0.6, 0.8. And if we want to draw the histogram for x, we can use hist of x, and this is the answer, histogram of x. Yeah, and of course, like curve or plot, we can change the color of the histogram like this, or box plot. Firstly, yeah, I'm going to show you the box plot of x. You know the box plot. There are two outliers here. Usually box plot helps us to find outliers rather than other information that it gives us. And okay, I will show you the histogram with another color, for example, if we need, like this. And we can change the title, for example, this. We can change the title of the histogram. Yeah. And if the format of your locale of your Windows is in Arabic or Persian, you can type Persian as well here. For example, if I go through this and change it in, for example, Arabic, if I can find it, yeah, for example, and apply it, and open another R. Now, histogram of x will give us this, and histogram main equals to, for example, Basrah. Yeah, this is the result for us vertically. Okay, and every other, any other title, if you need, you can type it in main. And you can change the vertical label or horizontal label as well. Okay, back to the file. Yeah, sometimes you note, for example, the gender of people rather than the rather than measuring a quantity. Sometimes you note a special qualitative variable like gender or job or blood type or something like this. Therefore, you have to enter the observations like this with a quote or quotation. W equals to C of F. You have to put F between quote or quotation, like as you can see here. F, F, M, 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 F, so on. And after that, table of W gives us the frequency of female and male people. And pi of table of W gives us the pie chart of the observations. And bar plot of table of W gives us the bar plot for the observations of gender. female, how many female, how many males. And here the percentage of female and percentage of males. Okay? And again, you can change the color of your bar plot, or you can, of course, use two colors for both of them, like this. If you note that here I wrote color equals to 6. It means that both of them are purple, okay? And for here, we have color 3 and 4, or 3, 2, 4. It means 3 and 4. Therefore, the left one will be in color number 3, then the right one is in color number 4. And there are a lot of many flexible bar plots, pie plots, histograms that you can see them. Again, in R, if you write, for example, example of bar plot, you can see, example of bar plot. You can see a lot of demonstration and examples of bar plot, like this, stacked bar, like this, 3 bar plot in the same page, or like this. And you can find which commands here. Here, in the right-hand side, you can find which commands will produce the left-hand side charts or plots. And this one, again, a stacked bar with numbers, and this one with the legend here. We can see the legend here. And this one, all of them can be drawn by bar plot. Okay. You can test this one as well. Okay. Okay, continue, and okay. Again, back to the vector, the quantitative variable x, 3.3, 5.6, and so on. Now I'm going to find the skewness of x. It's very important. You have to know that some calculations in R, in the based R, is not possible. But you can download and install a package from CRAN, as I told you, as I showed you, yeah, in CRAN. If you go to packages, you can see how many? Yes, a lot of, roughly about a little bit less than 18,000 packages there are. There are in R, and any of them can do a lot of calculations for us. One of these packages is moments. If you want to find skewness of x, firstly, you have to download and install moments, and then call the library moments, and then you can use the function skewness to find the skewness of x. If you want to install a package now, like for example moments, you can go to packages, and install packages, you will see the list of all mirrors first, and I can select, for example, Iran or any other countries. And after that, I can see a list of more than 17,000 packages here, like moments, for example, if I can find it. Yeah, if I can find it, maybe here. And then I can install, download and install it. Yeah, moments should be roughly about here. But there is another, yeah, it's moment. And if I can click on OK, I can download and install moments from Grand UMACIR. Otherwise, I can use the command install packages moments. It's easier rather than finding on the list. Yeah. And if I click on this, I can download moments, package moments for my calculations. And after that, after installing, downloading and installing the moments, I can call it by library moments and then calculate the skewness of X. Okay. Therefore, there are a lot of packages that we can use them if we need. Okay, in statistics, we know about a standard normal distribution, and with curve of d norm from -3 to 3, we can see the curve of standard normal distribution like this with d norm. Yeah, and of course d norm of 1 is somewhere roughly about here. Yeah, it's about a little bit more than 0.2. Yes, it is 0.24, d norm of 1. And p norm of 1 will give us the distribution function of normal standard distribution. If you know that d, we have in yeah, I think I can draw it for you. Yeah, this one is f. Okay, or in normal distribution it's phi, if I can write it here, phi. But capital F is the same as capital F of X. Sorry for the bad handwriting. It's from minus infinity to X. You know that. Okay. F, a small f, X, sorry, Y, for example, d of Y. And in R, this f can be calculated by P norm. Okay? P norm. P norm is capital F, or distribution function. Okay. And okay, P norm of 1 is, or for P norm of 1 we can say as well the probability of Z less than 1. Okay. And Q norm of 0.6 is, this one is capital F minus 1. Okay. Q norm is the inverse for P norm. That usually we find it on the tables at the end of statistical books. And R norm will generate for us a random number from standard normal distribution. R norm 10 means that we need to generate 10 numbers from normal distribution. And if we have a normal distribution but not a standard with mu equals to 7 and the standard deviation equals to 2, we can use R norm 10, M equals to 7, S equals to 2, that you can see here. Okay, like this. And these are the results. These 10 numbers are random numbers from a normal distribution with mu 7 and the standard deviation 2. And of course, with R chi-square 10, degree of freedom 4, we can have 10 numbers from distribution chi-square, chi-square distribution with degree of freedom 4. Or, for example, we can generate from gamma distribution with shape parameter equals to 3. Yeah, Yasin? I think someone raised his hand. Am I right?
Sorry, no question.
Okay. Therefore, with R norm, we can generate from normal distribution. With R chi-square, we can generate from chi-square distribution, where R gamma and R every other distribution we can generate from other distribution as well. For example, RT, RF, with R gamma, as I told you, with R gamma 10, shape equals to 3, or for example, RT from T distribution with DF3, we can generate 10 or 100 random number from student distribution, or for example, from Fisher. For Fisher, we have to define 2. You know that Fisher has 2. Fisher distribution has 2 degree of freedom, and therefore RF 10, 3 and 6 is required, and this will give us the random numbers from Fisher distribution. Okay, and another calculations that we need in statistics is, for example, hypothesis testing, like t-test. If we want to test mu equals to 5 against mu not equal to 5 with the same x that we defined at the before that. Firstly, we have to know that if they are, they are normal or not. With Shapiro test, we can test if they are normal or not. Shapiro test of X gives us a p-value, and with this p-value, we can find that it is not normal, of course, because it's less than, the p-value is less than 5%. And usually we compare with 5% as the type 1 error. Of course, they are not normal, but because we are going to test them, to test some functions in R, we continue with t-test. And we write t.test, t.test x, m equals to 5. And it will give us another p-value. This p-value is more than 5%, and then we say we don't reject H null, this one. We don't reject this one because the p-value is more than 5%. We don't reject this hypothesis, mu equals to 5. Therefore, if you need to test the mean of a population, you can use t-test. Or I can let you know if, for example, for t-test, if we say this one, and after parentheses we can say alternative equals to, for example, greater. Okay. Now we are testing mu equals to 5 against mu greater than 5. You know that in t-test we have one-tail and two-tail tests. For two-tail, it means that exactly the same, this one. But if the alternative hypothesis is not mu not equal to 5, and if it is, for example, mu greater than 5, we have to write this command, t.test x, m equals to 5, alternative equals to greater. Okay. And another calculation that we can do with R is fitting model, like regression. Now I have the same x, and I defined a vector named y, and with LM, abbreviation for linear model, with LM y tilde x, I can find the intercept and the slope. Intercept and the slope of the regression line. And usually, of course, we plot the scatter plot of x and y. We can use plot y tilde x, and then I can store the result of LMY tilde x in A, and again I can use AB line. You can remember that we use AB line for drawing a vertical or horizontal line in our plot. But for now, I want to draw the regression line in the scatter plot with a green color. Therefore, firstly, I will plot the scatter plot and then calculate the regression line, and then With AB line, I can draw the regression line like this. Okay. Testing regression, I'm sorry, with this testing regression coefficients. If we want to test the regression coefficient, for example, if we want to test the intercept or slope, we can use summary of A, which A is the result of linear model y tilde x, and the result is like this. We have a p-value for intercept, we have a p-value for the slope, and in this example, both of them are significant, both of them are significant and are enough far from zero. Therefore, our regression line is good to fit or predict, of course. Of course, we have to test the regression assumptions, and for regression assumption, we have to test the normality of the residual and some other assumption, and there are some comments in R for doing them. If we have time, I will let you know later. And here I will wrote an example of a data frame. Iris is a famous data frame about the flowers, special flowers iris, and with data iris we are going to call iris data frame from R, and with this command we can see all of the data, and with this one we can see just the first part of the data. As you can see, mod iris will give us list because the type of iris is a list, and if we need just the last column of iris, we can type iris $species, and this is the answer. This is the last color, and we can use table of iris $species again, that we use this before that, and pi of table of iris $species will give this, and for example summary of iris $petal length will give us this one, or histogram of iris petal length will give us this one. Therefore, if we have a data frame, we can do any other statistical calculations on this. We are almost at the end, and here I had a data collection named Hejazid in my Excel file, and if you call, and of course before that, if you install and download and install this library read XL, you can read your Excel file with this form. And of course I stored my Excel file into R in my data, and after that head of my data I can see the first part of my data. You can see the name of, because I didn't have any name for each column in my Excel file, automatically the name of them is X, capital X, underscore 1, capital X, underscore 2, and so on. And if I want to find the summary of the fifth column, I have to write summary my data x underscore underscore 5. And if we want to test the fifth column, the mean of the fifth column with 200, we can use from t-test, as I told you before that. Or for example, with LM, we can find the regression line between the 13th and 5th column of my data from my Excel file. And now okay, these ones were statistical, some of the statistical calculations that we could do with R, and now I'm going to show you maybe a little bit more graphs and surface and contours with R. If we want to draw x2 minus y2, we can find the position of each point in each dot in the surface with this. From -2 to 2, we will find x and y's as vectors, and then we define functions of x and y as we need. And with command outer, we can find for each x and y, I mean each you mean we have a lot of x and a lot of y. For each x corresponding each other y's, I mean all other y's, we have to find the position of the surface, our surface, with outer. And then we can draw our surface with persp x, y, z. And this is the result. Okay? Therefore, if you have a function, a two-parameter function like this as a surface, you can follow these commands, first this one, and then this one, and this one. With these 4 commands, if you change your function, you can see the new function if you need, the new surface if you need. And for exactly the same, for the same function, you can see the contour like this. It is the contour of x and y and z. And at last, with example of persp, that is my last example, you can see many type of three-dimensional functions like this or this. Many type of surfaces you can draw with R. Okay, and there is another library, RGL. I don't know if I have the library RGL. Yes, I have it here, and I can, of course, if I have x equals to y equals to this. This is my last example. And z or f equals to function x and y, x power 2 minus y power 2, and then Z equals to outer of x comma y comma f, and now persp. Note that persp of x comma y comma z gives us this, but persp 3D, which is a function from library RGL, gives us this, that we can move it by mouse if we need. This is a possibility in R. And if I write example of persp 3D, you can see the result of persp 3D as well, like this, or like this. Or maybe some other, I don't know. Yeah, not now. Okay. Therefore, you can use from R for very simple calculations in mathematics, in statistics, drawing a function, and of course, after simple calculations, you can do a lot of very advanced calculations with R, and you can write your own code, as I told you, and submit it with your name. Okay, if there is any question, I'm happy to answer if I can. Thank you very much for your attention.
Thank you, Doc. Thank you for time.
Thank you, Doctor.
You're welcome. Thank you. If there is any question, I'm at your service. Thank you very much. You can find a lot of tutorials in YouTube or other resources on the internet about R, and there are a lot of books, electronic books or something like this on the internet. You can find it, and of course there are some books in CRAN UMACIR as well. Here in contributed, you can find English document. You can find Chinese document if you are familiar with Chinese, or I'm not sure. I think there is no any Arabic documentation. I hope some of you will write a documentation for R, and you can submit it here with your own name if you want. I'm happy if one of you or some of you are interested. I'm happy to help you if you want to write a.
Thank you, Doctor.
Okay.
Thank
yeah.
you so much.
Yes, please.
Thank you, Doctor, so much.
Yes. Any question? Yes.
Thank you, Doctor. No, any question? Thank you for time.
Thank you very much. If there is any problem, if there is any question, if you are curious about R more, I'm happy to help you. My email is sarmat@umacir. You can find it easily on the Firdaus University of Mashhad site, and I was very happy to introduce R for you and some of your students. Thank you very much for your time, and I hope it was helpful. Thank you very much.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you very much.
Doctor,
Yes?
Doctor, can you open the camera? I need to see you. Please.
Yeah, okay. Okay, why not? Why not? Okay.
Oh, Allah.
It's okay. Stop presenting. I think I have to stop sharing first. Oh. Let me, please, 1 minute. TX NC FWZ. Okay, can you see me now?
No,
Yeah.
Doctor.
Yeah, Doctor.
I'm happy to see you as well.
Can you hear me?
Yes,
Yeah.
I can.
Oh, okay, good. I can't see you, but I can see the participant.
But my camera is on. I don't know why. My camera is on.
But I can't see you. I don't know why.
Okay. Okay, no problem.
I'm sorry. I don't know what is the problem. I don't know.
Ask from other students, maybe.
Doctor, don't worry. Maybe
Okay.
take with you.
I don't know.
Okay. That's
I'm
good.
sorry. I'm
Okay.
sorry. Yeah.
No problem. Don't
Yeah.
worry, Doc. Thank you for time, and see you later.
That's fine. Thank you very much.
Thank you, Doctor. Goodbye.
Thank you. Goodbye. Have a good time. Thank you very much.
Goodbye, Doctor.
Thank you, Doctor. Goodbye.
Thank you. Goodbye. Goodbye.